Beneath every productive garden, beneath every forest floor, beneath every meadow that maintains its fertility across decades of continuous growth without any human input at all, there is an infrastructure that most people who work with soil have never seen and that most modern gardening education has never adequately described. It is not the visible infrastructure of organic matter and soil structure, though those are real and important. It is something older, more fundamental, and more comprehensive than either, a living network of fungal threads extending through the soil in densities that, if stretched end to end, would run for miles beneath a single square meter of healthy ground. Mycorrhizal fungi. The word comes from the Greek for fungus and root, and it describes one of the oldest biological partnerships in the history of terrestrial life, a relationship between soil fungi and plant roots that evolved over 400 million years and that underlies the capacity of plants to grow productively in mineral-limited soils that their root systems alone could never adequately supply. Over 90% of plant species form mycorrhizal relationships, including every major crop species that agricultural civilization has ever depended on for food. The networks those relationships build extend effective root reach by up to 700 times, delivering phosphorus, zinc, copper, and water from soil volumes that uncolonized roots cannot explore. In exchange, the plant provides the carbon compounds the fungi cannot produce themselves. The partnership is ancient, mutualistic, and foundational to every productive ecosystem on Earth. Every farm that maintained extraordinary yields before 1950 was doing so on the back of this network, not because those farmers understood mycorrhizal biology, which was not described in detail until decades later, but because the management practices of pre-war agriculture happened to preserve the conditions under which the network thrives. Limited deep tillage left hyphal threads intact between growing seasons. Crop rotations including legumes and other mycorrhizal-dependent species maintained diverse fungal populations. Limited synthetic phosphorus input preserved the plant's metabolic incentive to maintain the fungal relationship rather than replacing it with soluble fertilizer that the plant can absorb passively without the metabolic cost of supporting the fungal partner. Post-1950 practices dismantled this network systematically. Annual deep tillage destroyed hyphal threads faster than they could be rebuilt. Synthetic phosphorus at high concentrations suppressed colonization by removing the plant's incentive for the relationship. Broad-spectrum soil fumigation eliminated fungal populations directly. Each practice was adopted for reasons that made immediate sense: easier planning, predictable fertility, pathogen control, and whose combined long-term effect on the biological infrastructure of productive soil was not recognized until the yield decline it produced across decades of continuous conventional management became too consistent and too widespread to attribute to other causes alone. Dinomyco granular mycorrhizal fungi inoculant is the modern intervention that restores what was removed. Link is in the description. At 900 propagules per gram in OMRI listed concentrated granular form, it delivers the mycorrhizal fungal populations directly to the root zone at the moment of transplanting or seeding, establishing colonization in new root growth before the plant is committed to the lower efficiency uncolonized pattern that depleted soils produce. Root mass increases of 40 to 60% and yield improvements of 20 to 40% compared to uncolonized controls are consistently documented in research on phosphorus-limited soils, not because the inoculant adds nutrients but because it restores the biological infrastructure that makes nutrients already present accessible to the plant. There is something worth reflecting on in the nature of this network, in the fact that the most fundamental biological infrastructure of agricultural productivity is invisible to the eye, operates below ground, and functions through a relationship of mutual exchange rather than extraction. The soil gives when it is given to. The network builds when it is supported. The harvest follows from an investment in something that cannot be seen or measured without deliberate attention but whose presence or absence determines the ceiling of everything visible above ground. The pre-1950 farms that sustained their productivity across generations were working in partnership with this network without knowing it existed. Restoring it is not an innovation. It is a return. What becomes even more important to understand is that mycorrhizal networks are not static structures sitting in the soil waiting to be used. They are responsive systems that expand, contract, and reorganize based on what the plant community is doing above them. When roots are active and continuously feeding carbon into the system, the fungal network expands into new soil zones, increases its branching density, and strengthens the biological links between plants. When that input is interrupted or the soil is repeatedly disturbed, the network doesn't simply disappear all at once, it slowly simplifies, losing complexity layer by layer until only fragmented pockets of activity remain. And that gradual simplification is why many modern soils still contain life, but no longer behave like fully functional ecosystems. The potential is still there, but the connectivity is reduced. Plants grow, but they do so in isolation rather than as part of an integrated exchange system. Restoring that connectivity is what changes everything. Once the network begins functioning again at scale, nutrients are no longer just added and hoped for in return, they are circulated, exchanged, and redistributed through a living infrastructure that responds dynamically to plant demand. At that point, soil stops acting like a container for inputs and starts behaving like a coordinated biological economy beneath the surface. Subscribe to In the Beginning and check the description for all product links. See you in the next one.